Hey, hi, what's up, everyone? This is Sumit K, and welcome to my channel, The Cloud Baba. In this video, I'm gonna talk about Open Policy Agent and how we gonna use Open Policy Agent to secure our Terraform, or if you are using Terraform open source or Terraform Cloud. So basically, this video, I'm gonna use the demo on Terraform Cloud. So before this, let's talk about Open Policy Agent. So Open Policy Agent is also known as policy as a code to your infrastructure as a code. So we will see what exactly is this. So the agenda of this call of this video is basically the what is policy in general. Then we will see the quick overview of Terraform and ISC. What is an open policy agent? Then we will look at OPA architecture. What is Rego? Rego is basically the code framework or the language in which you write your policy, right? So we will see a high level language which is called Rego. How does OPA works? And OPA playground, OPA playground is basically a web portal where you can where you can log in and play all the open policies, and test it. Lastly, we will see how to secure your infrastructure with OPA. We will do the demo on HashiCorp Terraform Cloud. So, um, first of all, what exactly is the policy, right? So, before we talk about OPA, we first need to understand the policy. So, policy is a set of rules, is a guideline, is a framework that designed to govern decisions and behaviors, right? And it ensures the consistency, compliance, and alignment with your organization's goal. So policy can be organizational, for example, HR policies, or it can be a technical, which is security policies, which we are going to cover it today. So, for example, if I talk about in general about the policy, so let's say an employee wants to work from home for 2 days. Like everyone is working from home or working from office, there are certain policies, right? So if an employee wants to work from home for 2 days this week, the HR system checks if that person adheres to the company policy or not. If it is not adhering the policy, then it's flagged or denied, right? Similarly, OPA policy, wherein a developer triggers an API call to deploy a resource. So OPA is basically sits in between them. It evaluates the request against the predefined rules. For example, no deployment on Monday, no deployment on Friday, or maybe you want to deny certain rules, AWS, security group rules on certain ports, or maybe any other policy, right? If you are working with Terraform infrastructure and all this, to allow or deny the actions. So this is where the OPA policy comes into the picture. Now, what is Terraform? Now, if you are familiar with the Terraform, then you know that it is you can declare your infrastructure with the declarative way. So we are moving from imperative way to the declarative way. So it's basically you write your code in a declarative mode, and then you set your desired state. So if you talk about imperative, it provides the step-by-step instructions. But if you talk about declarative states, it's basically what you want to see your end state, right? This is what the Terraform does. It has a state file, and you write the Terraform configurations file, and then you will apply those files or Terraform configurations file to provision your infrastructure. So basically, you create the states files, and the states file is basically map your current state and the desired state. Not going to cover the Terraform in details, but this is how it goes. You're gonna write the code, writing the Terraform manifest file, and then you understand what action you going to be happen, which is nothing is Terraform plan, and then you create your infrastructure using Terraform apply, and then you can also destroy using the Terraform destroy, and then you can destroy your infrastructure using the manifest file. Okay, so now coming to the topic of today, which is what is OPA, Open Policy Agent. OPA is a policy engine used to enforce policies across multiple services such as Terraform, Kubernetes, API Gateway, CI/CD pipeline, and many more services. Right? It is not designed for a single services. It is in general purpose. Right? So general purpose means as a policy, OPA is designed to work with any of your service. Right? It is open to every services. The policy as a code, since OPA is a policy as a code, basically it defined in Rigo. So Rigo, I'm going to cover it in upcoming slides. So policy OPA, basically when you write the policy, you write the policy in a Rigo. It's a high level language, right? And it's a purpose built policy language used to write your policies. Then we have decoupled policies. So decoupled policy means OPA sits next to your service, removing the policy logic from your service. So you no longer need to define the policies within your code. You're going to decouple it and you define the policy outside of your code, right? And then policy development life cycle. You are authoring, testing, and deployment of your policy. So um, offload policy decision, and basically you have a simple language. Rigo is a very simple language, so you can write your policy. It's pretty much easy. So OPA pretty much lets you do exactly that. We define a policy, which in the case of or for the case of sake of simplicity, can be a password requirement, right? For example, we have all encountered password policies where a system won't lets you create an account until your password meets the right criteria. Example, minimum length or number of special characters. So this is how something, policy you can define in a Rigo language. Okay. So this is the OPA architecture. This diagram here is basically, if you see here, you have a service. It could be anything, and could be a cloud service or any on-prem service. Let's say this time we have a Terraform, and then the OPA is basically is nothing. It's an agent which is running on your machines or anywhere if you want to run. And then we have a rego policy here, and the input file, which is in the JSON file. So OPA sits in your architecture together with the service we wish to enforce. And when a request when a request reaches our service, that request goes through the OPA. The OPA then check against the current set of policy which is defined in the rego, and goes back to the service with a message if the request is approved or denied. And because of its decoupled nature, implementing OPA in any current architecture is quite simple, right? So we'll see this when we cover the demo, how we are going to define the policy for Terraform, and what input file is. Basically we are generating the Terraform plan in a JSON format, and then we will have some query. The query is nothing, basically when you want to see the query meeting your policy against the your input data, right? And based on that, it will it will deny or allow the infrastructure provisioning. Okay, so now let's come to the very important topic is Rego. Rego is a part of OPA policy where you define where OPA policies are expressed in a high level declarative language called Rego. It's called Rego. Basically, it's specifically designed to express the policy concisely, right? So Rego provides a rich set of built-in functions that you can use to manipulate the data and perform the operations such as filtering or maybe aggregations, transformations, and etc. Right? So it supports some pattern. If you see in the snippet, it supports some pattern matching which allow you to match complex data structure against specific pattern or conditions. So um, here is an example. You can see there are two policies which is written in the Rego. The first one, it can be any name. You can basically package the Rego policies, the policies, You can make it any name. So I'm going to make it terraform.policies.friday underscore deploys. This is the name of my Rigo policy. And here I'm saying deny messages, and the which basically means if you are going to deploy your infrastructure on Wednesday, then the deployment is going to be denied. So I have I think I mentioned here Friday, but I'm putting Wednesday here, so don't get confused. You can put anything here, right? And just change the name, right? So it should be Wednesday here. So on Wednesday, if you want to deploy your infrastructure using Terraform, it is simply straight away going to evaluate the policy against your Terraform input JSON file, and deny your provisioning of the infrastructure, right? So it allow you to organize your policy into a reusable module and packages, right? Similarly, we have a second Rigo policies wherein we are saying that um, we are basically importing the input.plan as a TF plan, and then putting the deny message that anything basically it's continuing to change, watches the resource changes, and if anything which is open on internet on port 2022, the message saying that this particular cheese this particular is as allowed ingress for SSH port 2022, basically it's going to be denied, right? Okay, so what is the difference between Sentinel and OPA? You might have heard Sentinel if you are working with Terraform Cloud. Terraform Cloud has their own Sentinel policy. You can think about as a policy as code, but it's designed for the Terraform only. So Sentinel is a policy as a code framework developed by HashiCorp, and it's primarily designed to integrate with the IAC tool. Um, Terraform, it provides a policy engine that evaluates policy against Terraform configuration file during the deployment. Sentinel policies are defined using the Sentinel policy language and have a strong integration with the HashiCorp ecosystem of products, including their documentations and tutorials. On the other side, we have a OPA is an open source policy engine that can be used across a broader range of use case, and integrates with the various systems and applications, and is not limited to a Terraform. And because of this, OPA benefits from the contribution of diverse community of users and the contributors. So OPA can evaluate policies against the data, making it suitable for use case. Sorry, my bad. For the use case, and OPA can evaluate the policies, not just with the Terraform, but it's in general purpose. You can use with any other services like Kubernetes, and it's quite flexible, and pretty much easy to integrate with all the services. So the choice between Sentinel and OPA depend on your organization's specific requirement and use case. So if you are concerned with Terraform, where there is no additional scope and will not be in future, in that case Sentinel may be the good choice. Wherever selecting OPA will enable you to apply policy to Terraform and other things across the cloud stacks. So this is how does OPA works with Terraform. Basically, you have the configuration starts with defining your policy using the Rigo policy, and this is your Rigo policy. OPA evaluates those policy against the input data, which is the TF plan, to determine whether the policies are satisfied or not. So it does this by executing the rule defined in the Rigo Rigo policies and apply them to the input data. So you define the Rigo policy here, you have input data here. So OPA use a query based evaluation model where you can query the input data and get a boolean result which indicates that whether the policies are met or not met, right? So OPA receives the Terraform plan as an input in JSON format. This plan includes the details about your resource, that in Terraform, which is going to create or modify or delete any configuration like ports and buckets or VMs, VPC, anything, right? Recur policy are then basically applied directly to this Terraform plan. For example, they might require that all S3 buckets have encryption enabled, or that public EC2 instance restrict the SSH access. So this is what you can put it in your Rego policy as an example. And then OPA process the input by checking each resource in the Terraform plan against the Rego policy to see if they met the security standard which is defined in the Rego policy. And then finally, OPA generates a result that shows whether each resource in the Terraform plan complies with the policy or not. So if any policy is violated, like for example, if an EC2 instance has SSH open to all IPs, public IPs, OPA flags it, which provide specific feedback on the resource ID and give you the detail that this is a rule that was broken. So this integration with OPA makes sure that configurations follow security standards early in the deployment process, and by catching the non-compliant resource before they deployed, and OPA helps maintain a secure infrastructure and also reduce the risk of security issues down the line. So this is the OPA playground basically. If you see here, if you can just open this in this URL play.openpolicyagent.organization. So here, if you, this is the input file message world, and this is the output file. So if you basically, this is a policy, right? So here is a policy, here is the input file. You can think about the input file like a Terraform plan. So if you write hello, it will print here like true or false, because since we have defined the this world, so it is going to give you the value in a boolean like true, right? So this means that this is true and allowed. And if you all put together, and we want to secure our infrastructure with the OPA, so let's put all together and secure our Terraform deployment with the Open Policy Agent. We create the test manifest file, local validations, commit to Git, automated testing and deployment. So I'll cover this with the Terraform cloud only, but let's just let's just see how OPA, you can use it and install it, and how you can hands on with the OPA. So let's get back to my console. So yeah, so before we going to the console, so this is a demo that we are going to perform the Terraform workspace. We are going to commit our code. Basically, not we are not going to commit our code, we are going to use the Terraform console. um, uh, Basically, we are running our code, our local, but it is going to be executed on the Terraform workspace, and we will apply the open policy agent on the Terraform cloud, because it's pretty easy to use and it's pretty easy to understand. You will understand it how the Terraform cloud can use both Sentinel and open policy agent. And then if the open policy agent basically going to sit in between, and it evaluates all the policy which is written in Rego, and based on that it will allow and apply the infrastructure, or if it violates, then it's gonna stop it and failed here. Okay, so yeah, let's back to my terminal. So just to show you how OPA exactly works, so if you want to deploy OPA on your machine, so you can simply OPA installation. So just get started with this official document, and here you just run this command curl, and it's gonna download the this file, OPA file, and you just need to give the permission. So I have already downloaded it. Okay, it's almost full, no worries. So I am into my, so this is the, which one? So yeah, let me go to OPA demo. This was my file, and here I have already downloaded this OPA executable file. So it's you, when you run the curl command, it is going to download the latest executable on your systems. So I already here, and if you look at the Terraform code here, basically this is my folder, and I have this main.tf file wherein I have the provider, the access key and secret key. Now try this access and secret key in your lab. I'm going to rotate it after this video, and here I'm going to create the AWS S3 bucket, and then the controls. Then I'm going to create the ACLs on the bucket, and AWS instance and a security group, right? So, and I'm also going to define a rule that this is going to be a rule that everyone can SSH on port 22 from public internet. So which is basically is something that I am violating the organization's policies, and I'll define my Rego policy that this should be denied if you accidentally open any rules in your code, right? So I have also a folder called OPA1, and then I have policies. Under policy, I have two Rego policies basically. The first policy, which I'm saying the package terraform.policies.friday underscore deploys. The name I'm taking it from the name of the policy. I'm saying the deny message Monday because today is Monday, so I'm saying that anyone who wants to deploy this infrastructure, it's going to be denied, right? Because today is Monday, we don't want any releases on Monday, right? And then we have a public ingress Rego policy, which basically says that anything that is listening from internet on port 22 to 2022 should be denied, right? So this is what we are going to do in our demo. But before this, let me just show you something here. What exactly the OPA exactly works, right? So let me just okay. So right now, so let me just first do the Terraform minute. Okay, so now I'm going to run Terraform plan, and I'm basically generating the plan dot tf plan. So this is how you run the Terraform plan and you generate the outputs, right? And then anyone can review this Terraform plan. But OPA understand the JSON language, so we need to convert this plan to a JSON language. Remember that I told you there is two important things when we talk about OPA: the input JSON file and the Rego policy, and then the results, right? And then how we are going to query it. Four components, right? So you know, let's first convert this in a JSON. So we have plan dot tf plan, which I'm going to convert plan.json. So if you see here, I have the JSON file here. So if you want to look, you can. It's going to be okay. Maybe you're not able to see it here, but you can see it from here. Yes, sorry, my bad. I think it was plan.json. Sorry, my bad. Plan.json. Yeah, a lot of things here. So let's run the OPA. Okay, so I have the, if you see here, OPA, the executable file is OPA. So what you're gonna do, simply OPA, and just run this OPA and run plan.json file. Yeah, so now we are going to run policy agent against this input data, right? So now you can run data here. So you see the OPA is going to um, basically display the data, right? um, Means you we should be able to view the contents of your input document. So it has a lot, right? So let me just um, let me just view this using the keys, right? So if I do data and keys, so this is how we can discover the top level keys of our data by simply using the Rego expressions, right? So Rego basically creates the keys and the datas, and you can view the data uh, when in a keys format. So here the first thing is resources change. The key resources change contains the changes that will be made to target environment, right? And it includes a resource that will be created, updated, or destroyed. So if you are concerned about changes to a target environment, this is the place to look. So you can see that this is the address, instances, and what changes is going. Basically, it's going to create it, right? So this is what you can see it. And then you have a something called configuration here, which is a important key to understand, which contains the rendered configuration in the JSON format. And another important keys is planned values. So planned values keys contains the value that will be used to create the resource, and it is essentially a merge of what is in the configuration key and in the variable key, right? So variable key is nothing. Here you see this variable key. Where is the variable key? Okay, so variable key is not here, but if you have the variables key, then it shows the merge of both, right? And if you want to know what's in the rendered configurations, this is the place to that you can look at, right? If you want to run certain keys, then you can also run data um, dot maybe resource changes. Let's say resource changes and keys. So this is where if you want to see the resource changes, and this is what you can see here. They basically you want to know what's changing about your environment, right? Unlike planned changes, this key gets directly to the point. Each entry in the resource changes key contains the address of the resource, the change that will be made, and the before and after the values, right? So this is what you can use to just play around. And yeah, there are a lot of things you can do, but let's come out from here. I want to show something. Evaluations, how you can evaluate um, your policy against your Terraform, JSON file. So to evaluate the policy against the plan, you hand OPA the policy, the Terraform plan as input, and ask it to evaluate. So there is a command. Yeah, this is the command. Basically, I'm running the OPA and then evaluate it. The data is coming from OPA one for directory and then policy directory, and this is one of my Rego policy. The file name is input file name is plain.json, which is nothing in a Terraform plan. And this is what I'm going to query, which I told you, right? Data.terraform.policy.public ingress deny. If you look at here in the um, this particular policy, this is what we had defined, the package name Terraform policy public ingress. I'm just using data dos and then whatever the parameters here, the deny messages. Okay, here you can use the same query. Once you run this, you'll see this the result. That so in the result you can see this saying that going to be denied. The value is not printing. I don't know why it's not printing, but let's just run the another policy maybe. um, yeah, this one is also we have second policies Friday deploys. Let's run this one. So yeah, here you can see that it is straight away meeting the criteria. right. So which means that the result confirms that our policy is working as expected. The deny rules was triggered because the condition in the policy matched, and it returned the message that today is a Monday, and the text is saying deny, right? So today is Monday, you can't deploy this the your IAC code because of this policy, right? So the condition here is here is that if you see the policy here, the condition is here. We specifically mentioned that the time weekdays is and time now as Monday, uh, right, is set to true, and the message is today is Monday was included in the deny response, right? So this is how that you can validate your policy against a file, but it's going to be very complicated when you are doing or matching a certain conditions on your complex code. And so I don't want to make it much complicated, so let's get back to the our original demo which we have planned for Terraform Cloud. Okay, so I have a um, I have a Terraform code which, let me show you here. Yeah. So if you look at here, this was my Terraform code. Again, the same code, but the only difference is that I am adding this particular block of Terraform Cloud, wherein I am saying that my organization name and the workspace, so that my code can run remotely on the Terraform Cloud. So I'm going to make it very simple. The policies again remain same. The only thing I just changed the name of this policy from Friday to Monday, and the policy is still same. So there are two Rigo policies and the Terraform code, and now we are going to run it on our Terraform workspace. Let's take a look at the Terraform workspace. So I have a Terraform workspace called Terraform AWS OPA. So this is the particular workspace. If you see here at the setting, if you go to the policy, I have a policy called policy one. You can create a policy, but let me show you how to create a policy. So when you create a policy, you will select the policy framework, Sentinel, and Open Policy Agent. So I told you the difference between them, but I'm going to go with the Open Policy Agent. You're going to make it something called policy 2 or any appropriate name. The description of the policy here is the advisory behavior. So it failed policy produce a warning. I'm not going to enforce it, but it's going to give you an advisory. Mandatory, it's failed policy stop the run. When you select the mandatory, it basically stop the your Terraform run. And then you query it, basically Terraform data.terraform denied. So I told you, right, the package names like here. This is my package name, Terraform policy Friday to deploy. So what I'm gonna make it here, I'm just add data and the this one, the what exactly you're going to evaluate. This is the rule expression or query, and then you put this code. You put your Rigo code policy as a code here, right? And then you create the policy. I'm not going to create it since I have already created this policy here. If you look at it here, so I have created the second policy, the Rigo policy, for denying the ingress public access on port 2022 from the internet. And I have also attached this policy sets. So I think it's not here, but the policy is pretty much clear, and the enforcement behavior is mandatory. Okay, so if you look at the policy sets here, I have a policy set because policy sets are the one the component that applies on your workspace label. You cannot directly attach the policy to the workspace, but so you need to create a policy sets, right? So this is the policy sets. If you look at the policy sets, there is a this policy one, and you can add multiple policies. If you had more policies, you can attach more policies. I think Terraform Cloud has certain limitations that you cannot has some quotas also. You can't add more than certain policies. So I'm just stick to one policy one, and we can modify it just to test around this particular demo. Okay. Now I'll do one thing. I'm going to run this particular infrastructure. So when I run this, it is definitely going to stop my provisioning, because the policy, the first, not stop, yeah, sorry, it's going to stop because because my policy is there, and it's in force as a mandate, right? So the first thing that you need to run Terraform login. So Terraform login is important when you run the Terraform login. Basically it goes and you just say yes. It goes to the Terraform cloud asking for the API token. So right now I'm going to take this 1 hour. 1 hour, this 1 hour is fine. I'm going to copy this one to here and put enter, and it retrieved the token from the Terraform cloud and has been authenticated. Now I can run my, you know, Terraform. Let's directly do the Terraform apply without wasting a time. So so I'm using Terraform cloud, which means that your execution is not happening on your local machine. The execution is going or is running on the Terraform cloud. So you see this. This is the, if you want to see your execution, so you can simply click on that, or I can simply go to my um, organizations and sorry, my bad. So here is my, see, it's already planning. If you look at here, it's already triggered because I run Terraform apply, and it's going to um, create these many resources. See, AWS default VPC instances, bucket ownerships, bucket example, and you just see here, this is the OPA policy that I have told you was attached to my workspace, and it has stopped my executions. Why? Because this policy set is applicable. It's denying it because it says, if you click on this, it says this value, AWS security group dot example has this as allowed ingress for SSH port 2022. So this is what this saying, that hey, your code has certain certain policy, certain component that actually violating the policy. And what are those components? Is basically this one. This particular block is saying that you are directly exposing your security group to the public internet on the port 2022, which is going to be a security security issues, right? And this is checking against this your Terraform plan by the OPA RIGO policy, right? And you can see here nothing is moving forward now. It's stopped here, right? So this is how your OPA policy is um, stopping you in the early stage, right? So let's say you can also go for the advisory. Like if you set it advisory on the policy, then it give you the advisory, and you can simply just see those advisory. I can move forward, right? So let's do one thing. Let's go to the policy again, and the policy this time. What I'm going to do, I'm going to do the second policy, which is Monday deployment. So let's go here. And what I'm going to do, I'm going to modify this policy, and the query that I'm going to use is this one, right? This is very important, right? If you do not mention it, then this will might create a problem. So let's see if my this policy is basically evaluated against my input data, right? Which is nothing, which is my plan, right? So it's been updated. So yeah, here also you can see that it's failed. My last apply got failed because of the OPA policies, right? So because I'm doing some violations, so let's run it again. You'll see it again. So now go back to the, so you here see here your planning is in queue, and just wait for Wait for a few seconds. It will fail. It will stop again. The OPA policy will evaluate the JSON file or the Terraform plan. It will stop the run. See here. If you click on hit here, this is what the message is saying. Today is a Monday. Today is Monday, so you cannot deploy anything, right? So Monday is not a release day, so you can't do any changes on Monday, and simply straightforward denying the code executions, right? So this is how you can evaluate it. So I hope you have a great understanding of OPA.